This is chapter 5, problem number 4. The lucky number for this problem is number 8. This is your lucky number. Okay, so let's look at this one. There is a beam. It turn it this way. It's bended. Look at the joint at point A over here. If it's just like a regular pen like this, then it's going to rotate because we have the moment pushing it, the force pushing it down. Each of these is going to make it rotate clockwise. And therefore, if it's this type of connection over here, at point A, it must feel the moment. So when you have all these forces acting on the beam, at point A over here is going to feel the moment. So the question asks to determine the components of reaction at the fixed support A. Okay, so over here, not only asking for the moment, but also the X and Y component of the force. First of all, let's get the X position. By the way, let me write down the magic formula. Moment at a certain pivot that is equal to X times the force in the Y direction minus Y times the force in the X direction. Okay, 60 degree, what is the X component over here? So it's 3 meters, 3 times cosine of 60, and that is, some of you may already get it, it is 1.5. Okay, and what about the Y component? So that should be equal to 3 times sine of 60, that is 2.60. So it's 2.60. Okay, so let's look at all this. So what is the X and Y component over here? The coordinate. So over here, 1 meter over here, so it will be X will be 1 plus 1.5 is 2.5. The height will be 2.6. Okay, so this one, only the X will be, add another meter to it, is 3.5. Over here, it is 4.5. Okay, and the Y value is 2.6. Over here, we have a force. It's acting 30 degrees below the x-axis. So what is the x component and the y component? The x component, we know that is positive. So this one, the x component will be 400 times cosine of 30, and that is equal to 346. 346. As for the y component, maybe some of you already figured it out. Is half, should be half of that, and is half of that is 200. So 400 times sine of 30. So that is equal to 200. So that is the force. Okay. And it's going down, so it's negative. Okay, so now we are going to use this formula. All right, so I'm going to put, just to save space, with this force, the Fx is equal to 346. Fy is equal to negative 200. Okay, so I can use this space over here. All right, now I'm going to sum that up and see what happened and see what the moment over here will be. Okay, so with this force, it will be x times force in the y direction. X is 2.5. 2.5. Force in the y direction is negative 200. So negative 200. Okay, with the same force minus the y component, 2.6 times F in the x direction, which is 0. That's why I ignored that term. Okay, so another one, the x for this one is 3.5. So 3.5 times negative 200. That is the force in the y direction. So I add another one to it, okay? So the x is 4.5 times negative 200. So all this is going to be negative because it's going clockwise. And the last one is a little bit complicated because we have both x and y, but it's not that complicated. All right, so x over here, we're still using the same formula. X is 4.5, so 4.5 times force in the y direction, that's negative 200, minus y that is 2.6 times force in the x direction, that is 346. So if we do everything, so what I have here is, okay, 2.5 times negative 200 minus 3.5. Oh, this one, I think this is positive over here. Okay, sorry, my mistake. So it's a positive plus 3.5 times negative 200, and then plus 4.5 times negative 200, and then plus 4.5 times negative 200, and minus 2.6 times 346. So that's the total moment. So the total moment is negative 3900 roughly. Okay, so the unit will be Newton meter. So that's what the moment over here, point A, will face. Other than that, so let's look at, so what about the force in the x and y direction? So pushing it down is 200, 200, 200, so the 600, and plus this 200, so it's 800 pushing up. In the x direction, because it must be balanced, otherwise it's going to move. In the x direction, 346 is going to the right. So over here, there must be 346 going to the left to balance it out.